Today what we will be doing? We will be doing the measurement of internal diameter and depth of a given beaker using vernier calipers and hence find its volume. Now for doing this thing, what we need a beaker, glass beaker we will be using. Students, as you all know, this is a wooden scale having centimeter marking. Now least count of this scale is how much? The total 1 centimeter divided by 10, that is 0.1 centimeter, that is 1 millimeter. The problem of this kind of wooden scale or linear scale is that by this particular scale we can find 1 point after decimal. So this kind of thing cannot give us accurate result. For getting an accurate result or 2 points after decimal, we will be using vernier calipers. This is the vernier calipers. As you can see, this device is a vernier calipers. In this vernier caliper, 2 particular scales are available. One scale, this long scale, this is called main scale, and another scale which is present here, this is a small scale. As you can see here, this is a small scale present over here, and this is called the vernier scale. This is called the vernier scale. With the help of both the scale, we will be finding the result and we will be getting 2 points after decimal. Now as you all can see, this is a diagram of a vernier calipers. In this vernier calipers, we are having a main scale. This long scale is called the main scale. Inside this thing, one small portion is there. You can see a small scale is used, that is called vernier scale. Now jaws are there. There are 2 jaws. One jaws this side, upper side, which is to find the internal things, like if you want to find diameter or length of anything inside this thing, you can put it here. Like if I want to calculate external diameter of anything, we can calculate with the help of these jaws. But as you can see in this particular picture, we are finding the internal diameter of a picture. To find the internal diameter of the picture, we will take help of these 2 jaws. So these 2 jaws can be taken for finding external diameter. These 2 jaws can be taken help to find the internal diameter. As you can also see, and the back side of the vernier calipers, one extended tail kind of portion is there, that is also used for finding the depth. Like we will be vertically holding the vernier calipers, we will be putting it inside, and this particular tail will be inserting inside. With the help of that thing, we can find the depth of the beaker. Now with the help of main scale reading, with the help of vernier scale reading, total we will be finding the reading, total scale reading. Now for finding this particular apparatus, we first need to calculate vernier constant. For vernier constant calculation, we need to show the apparatus. Students, as you can see, this is a vernier calipers. Now in this vernier calipers, first you have to concentrate on this thing. This is the scale which I was talking about. This is the main scale. This total scale is the main scale. Now here is lying the vernier scale. This small portion you can see as a vernier scale. For vernier scale, no particular order has been given, that is neither in centimeter, neither is millimeter. This is simple, some lines has been given, as you can count here. It is starting from 0th line and ending at 10th line. So ultimately total how much is there? Starting one is 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now the main thing what we will be doing here, we want to calculate the vernier constant for this device. What we are doing here, just check here. 0th point, that is a starting point of the vernier scale, the 0 line is matching with the 0 line of the main scale. So these 2 lines, 0 line of the main scale and 0 line of the vernier scale, they are matching. But that important what I want to tell you, see here, that last line, that is the 10th line. The 10th line of the vernier scale is matching with the 9th line of the main scale. So this is the point by the help of which we will be calculating the vernier constant. So first once more check you this thing, that 10th line is matching with the 9th line of the main scale. 10th line of the vernier scale is matching with the 9th line of the main scale. As I have shown you students that first one MSD, that is one main scale division, MSD stands for main scale division. 1 MSD equals to 1 millimeter, that is the least count, the minimum distance what you can calculate with the help of a main scale is equals to 1 millimeter. Now just now you have seen in the apparatus that 10 VSD, that means 10 vernier scale division is equals to 9 main scale division. So 10 VSD equals to 9 MSD. So 1 vernier scale division will be how much? 9 by 10 MSD. Now that will be how much? 0.9 millimeter, because 1 MSD is equals to 1 millimeter. So 0.9 into 1, that will give me how much? 0.9 millimeter. Now what I will calculate? I will calculate vernier constant. Now vernier constant is what? Vernier constant is equals to 1 main scale division minus 1 vernier scale division, that is giving me how much? 1 minus 0.9 millimeter, that is equals to 0.1 millimeter, that is equals to 0.01 centimeter. So vernier constant of the device what we are using is equals to 0.01 centimeter. Now Now students, we want to calculate the volume of this particular beaker. As you can see this beaker, this is a cylindrical beaker. We will be first calculating its internal diameter and we will be calculating its height, then by that formula of volume we will be calculating its volume. Now as you can see in this particular Vernier calipers, as I have told you earlier also, that there are two kinds of jaws, one these jaws and another set of jaws is this one. Now with the help of these lower jaws we can find the external diameter. You can see I can find the external diameter here. Now with the help of the opposite jaws I can find the internal diameter. This internal diameters I can calculate with the help of these jaws. So what I am doing here, I am putting the jaws inside the beaker and I am pressing it like this, I am making it tight, then I am removing this particular beaker. Then I will be calculating the main scale reading and I will be calculating the Vernier scale reading. Now you see here, when I am focusing on the main scale reading, first you see which line the 0 mark of the Vernier scale is crossing, that I have to see. Now as you can see here, the 0 mark is just crossing 4.6. So main scale reading will be 4.6 as Vernier scale 0 has crossed the main scale 4.6. So here in the main scale reading I will be writing 4.6. Okay. Now I want to calculate the Vernier scale division. For seeing the Vernier scale division among this particular line starting from 0 to 10, I have to see which particular line is exactly matching with the main scale line. Now for that thing I have to check this thing. As I can see here, you also concentrate, see here the 7th line of the Vernier scale division is matching exactly with one line of the main scale. The 7th particular line, the 7th number line of the Vernier scale is matching with the main scale linear line. So here the Vernier scale division will be 7. Now what I will be doing, I will be calculating the Vernier scale reading from here. So 7 I got the Vernier scale division. So 7 into Vernier constant, that will be giving me how much? 7 into 0.01, that is equals to how much? 0.07 centimeter. Okay. So total diameter will be how much? 4.6 plus 0.07, that will give me how much? 4.67 centimeter. So for this particular beaker, what I am getting its internal diameter to be 4.67 centimeter when I have done one time reading. Now I will be repeating this thing for 3 times. Once this way I have taken, then I will rotate and then I will take 3 time reading and I will put the value in observation table. Now we want to calculate the depth of this beaker. How to calculate depth of the beaker? The same Vernier calipers we will be using, but we will be using the back portion now. You can see when I am pushing it up, one extended tail kind of thing is coming out, that I will be putting inside. Now here I am putting this thing inside and exactly when it is touching the lowest portion or the bottom portion of the beaker, I am stopping the thing. Now I am leaving it out. Now I am again repeating the same process. I will be taking the main scale reading, I will be taking the Vernier scale reading. Here as you can see, when I am putting it here, the main scale reading is coming how much? It is coming 7.4. The main scale reading is coming, no, it is very near to 7.4 but crossed 7.3. So which reading it has crossed, that you have to take. So it has crossed 7.3. So I will be taking the main scale reading to be 7.3. Done. Now Vernier scale division, as I have told you that you have to see among these Vernier scale lines which line is exactly matching with the main scale line. So here which line is matching, let me check it once. Here the first line is only matching. So first line matching means Vernier scale division is 1. Just check it all of you, that 0, the first line is exactly matching with one line of the main scale. So Vernier scale reading will be how much? 1 into Vernier constant. So 1 into 0.01. Okay. So how much I am getting here? I am getting here 0.01. Okay. So 7.3 centimeter was the main scale reading. Vernier scale reading is coming how much? 0.01 centimeter. So total reading is coming 7.31 centimeter. In this way I will be repeating depth calculation 3 times and I will be getting the average depth. So students, we will be calculating we will be doing the observation table for the measurement of the internal diameter and depth of a given beaker. So as you can see, already we have calculated the internal diameter, it was coming 4.6 was the main scale reading, Vernier scale division was 7, so ultimate reading was 4.67. Depth we got the main scale reading 7.3, Vernier scale reading we got 0.01, ultimately total reading is coming 7.31. Okay. So ultimately by using this formula of volume we can calculate pi d by 2 whole square h, you can calculate the volume. Now this calculation is your task.